So let's take a look at this right here in terms of dimensional analysis, because like I said, if you're going to learn anything in this course, you want to learn the technique of dimensional analysis. It'll pay dividend when we get into stoichiometry. Okay, so dimensional analysis, also known as the unit factor method. And in this particular case, what we're going to do is we're going to learn how to use this technique to solve a whole host of problems. The key to dimensional analysis is the conversion factor. A conversion factor is like a translator. It takes one set of units and translate it to the desired set of units. So when you have a problem, okay, this is just an analogy, but the whole idea of dimensional analysis is that in the problem that you have, you're always going to be provided some given information, and then you're going to be asked a question. That's the goal. And in the process of answering that question based on the data that you receive, you've got to go through this translator in order to do that calculation. So the translator is taking one set of unit and then converting it based on the confines of the question to desired answer. So that's the whole idea. It's like a box where you put in the information and you get your answer at the end. Okay. So you guys do this every day without even thinking about it. Suppose you go to Europe and it tells you that the exchange rate is 17.25 euros equals $1. Okay. And you need to figure out, the exchange rate is 0.69 euros is $1. This might have been a while back. And the question is, how many dollars is 17.25 euros? Well, the key here is that this is the given information. This is the given information. And that's defined by the problem. And this is the conversion factor. The conversion factor is like an equality. Even though they're not the same, like miles per hour. If you're going 60 miles per hour, that's a conversion factor. One set of unit is distance, the other set of unit is time, and yet they're equal for that situation. In 1 hour, you're moving 60 miles. That's why we can say that it's an equivalent, because for that situation, it works. 60 miles equals 1 hour. Here, 0.69 euros is $1. For this particular situation, they're equal to each other. So you can put that as a ratio right here, because 1 over 1, if something over something is the same, it's like multiplying any number by 1, and any number multiplied by 1 gives you that same number. Okay, an example might be 12 and 1 dozen. 1 dozen means 12. Okay, so here $1 is 69 euros. So if I want to convert 17.25 euros, the key here is to see this unit right here. That has to be in the denominator of your conversion factor. Only when it's in the denominator do the two units cancel out and you get the unit that you want remaining. So in this particular case, and again, you guys do this without even thinking about it, you take 17.25, multiply it by $1 and divide by 0.69, and you get your answer based on that conversion. And that essentially is what dimensional analysis is about, okay? Here is a question. How many miles is it to the closest star 4.2 light years away? And the question is, how do I convert 4.2 light years to miles? And the answer has to do with the conversion factors that you use. Here are a bunch of conversion factors. The given information is 4.2 light years, and the desired information is miles. So that's my goal. I have to go from light years to miles. Whenever you do a conversion dimensional analysis, always start with the given 4.2 light years, and then find the conversion factors that will allow you to convert that information to the desired units. Okay, so light years is the number of years the number of the distance light travels in 1 year. Okay, the distance light travels in 1 year. So let's say that this is 1 year, 4.2 light years. So it's basically 4.2 years for light to travel. So the first thing that we want to do is find this right here. And why do we want to do that? Because we got to convert time to hours, because our final conversion is miles per hour. So if this is year, then the first is year, days. Okay, let me try and get a better pen here so that you guys can see this contrast better. Sorry about that. Oops. Do this. Okay, so the years will cancel out. The next conversion factor will have days on the bottom, hours on top. Okay, days on the bottom, hours on top. And I'm just going through the sequence of converting one set of units to the other. And then I can convert hours to miles using this conversion factor. So if I do this right, the years will cancel, the days will cancel, the hours will cancel, and I get an answer in miles, which is exactly what this question is asking. Now, where do I put the numbers? The numbers here goes with the units. For 1 year, there's 365. For 24 hours, there's 1 day. And for 1,862,282 miles, there's 1 hour. All I got to do now is the math. And so if I take my calculator, and let me show you my calculator here so that you guys can see how that works. Okay, here it is. So I'm going to take 4.2 and I'm going to multiply. See where it's multiplied here? I'm just going to multiply it, because when you divide by 1, you don't want to waste time on that. Any number divided by 1 is the same number. So I'm not even going to enter that. I'm just going to take 4.2 times 365 times 24 times 186 282. Okay, and I'm going to say equal. So that would be my answer. And that's dimensional analysis. You let the units set up the equation for you in this. So the final answer to this problem, how many miles is the closest star? It would be 6,853,687,344 miles. That's the way you would do dimensional analysis. Again, you let the unit set up the problem for you. Okay, so let me clear this, and then we can take a look at the answer here. Here it is right here. Let me do another one here. Let's say that I want to do this, 65 miles per hour. Suppose I'm traveling at 80 miles per hour. How much is that in centimeters per second? Okay, 80 miles per hour. And I want to go centimeters per second. That's the goal. That's the given. So what conversion factors I need? The conversion factors I need is I need to take hours and convert it to seconds. So I know that in 1 hour, that's 60 minutes. And in 1 minute, that's 60 seconds. So I can use that for my time change. And then for miles, I can go from miles to, let me just find out if there's a convenient conversion factor in my appendix. that will take me from miles to meters. And it shows that in terms of length, yeah, we can do that. We can do feet. 1 mile is 5280 feet. Feet to inches, and then inches to centimeters. So those are the conversion factors that I could use. And if you have a more direct conversion factor, that will work as well. So here are the conversion factors that I'm going to use. I'm going to say that 1 hour equals 60 minutes. 1 minute equals 60 seconds. 1 mile equals 5280 feet. 1 foot equals 12 inches. And 1 inch equals 2.54 centimeters. Okay, now I'm going to clean this. I'm going to show you how easy it is to set up. And this is what you want to remember. I'm always going to start with the given information, 80 miles. And I don't ever want to do this. Put a slash, because when you make it a slash, you forget that the hours is a denominator. So 80 miles per hour is that. You can write it this way, but I prefer it this way when you do the math. Then it's just a matter of doing the conversion factors. Hours is in the bottom here, so hours has got to be on top. Only by putting it on the numerator can it cancels. And then we can see that it's right here, minutes. So we've taken care of that. And then minutes will be here, and then seconds will be down here, and we've taken care of that. So that will convert my hour to seconds. Then I'm going to convert miles. See how it's on top? I got to put it in the bottom. Only by putting it in the bottom will it cancel. And then I got feet on top. So that takes care of that. I'm going to continue over here. And then feet on the bottom, inches on top, and then inches on the bottom, centimeters on top. So that's going to be my setup. That's the way I'm going to arrange this problem so that all the units cancel and I get my desired units of centimeters per second. All I've got to do now is put in the numbers. Over here, I've got 60 going with minutes. I've got 60 going with seconds. 1 minute, 60 seconds. I got 5280 right here, 5280 feet is 1 mile. I've got 12 inch is 1 foot right here. And I've got 2.54 centimeters is 1 inch right there. And if I look at the units, the miles will cancel, the feet will cancel, the inches will cancel, and I get centimeters. The hours will cancel, the minutes will cancel, and I get seconds. And all I've got to do now is the math. Okay, all I've got to do now is the math. So let's do the math. Again, wherever you have a 1, you skip that step. So I'm just going to start with 80, and then I'm going to divide by 60. Divide by 60, and then I'm going to divide by 60, and then I'm going to multiply by 5280, and then I'm going to multiply by 12, and then I'm going to multiply by 2.54. Okay, and so that will tell me 80 miles per hour is 3,520 centimeters per second. And notice that when I did my math operation, I streamlined it by just going directly to the math operation rather than multiplying by 1, where I see this in dimensional analysis. I skip that because, again, multiplying by 1 and dividing by 1 gives you the same number. So why risk the error in the calculation? So in this particular case, I think I got a better it's still 3,576. And in this particular case, because our original data has, I should have put 80 here, 2 significant figures, my answer should be rounded off to 2 significant figures, or 3,600 centimeters per second. Because in this calculation, conversion factors have infinite number of significant figures. Okay, you don't limit the number of significant figures based on these intermediate calculations because they're exact. Always based it on the data that you're given. The data has 2 significant figures, your answer should contain 2 significant figures. So that's basically how you want to set up these problems right here. Okay, when you want to convert, say, 155.5 pounds to kilograms, you can do that in one step. You can basically do this right here. You can say, let me clear this screen. You can say that you have 155.5 pounds, and then your conversion factor is pounds to grams, grams to kilograms, and that's your answer. Or you can do 155.5 pounds to kilograms if you have that conversion factor directly. So it's just a one-step calculation, sorry. Okay, it's just a one-step calculation. But your answer should contain 4 sig figs. Why? Because your data has 4 sig figs, always based on the data that you're given. This question right here, Prius automobile has 11.9 gallons for full tank. How many milliliters is that? You guys can do that. I want you to do this problem. I'm going to set this problem up, and I think and then I'll show you one more problem, and then I think we're done. So I'm going to clear this up for you. Okay. So in this one right here, you see how I give you the density of 0.750 grams per milliliter? That's a conversion factor. Okay, the density in this problem is 0.750 grams equals 1 milliliter. You want to use that in dimensional analysis. So if the gasoline has a density of 0.750 grams per milliliter, what is the mass of this volume? Let's say that I have 5.50 liters. Okay, let's say that that's the volume that I have. Well, I want to know the mass in grams. Okay, I want to know the mass in grams of 5.50 milliliters of density. Well, the first thing that you need to do is you need to convert, see how these two are different units? You need to convert liters to milliliters. Sorry. You need to do that. You need to convert liters to milliliters. Then you can use this to convert milliliters to grams. And that's specific for gasoline. Okay, so this right here, we know it's 1,000 milliliters to 1 liter. And we know for gasoline, it's 0.750 grams is 1 milliliter. So that basically takes the volume and using density as a conversion factor, converts it to mass. Dimensional analysis is amazing, okay? It's amazing because even if you don't know the mathematical formula, the mathematical formula will present itself if you do the units. If you do the units. The last thing I want to mention is this last problem. It takes about 8 minutes and 25 seconds for light to travel from the sun to the earth at 186,282 miles per hour. How many pennies is this worth? So if you go to Canvas, because I kind of help you with this particular problem in Canvas, I actually set up the dimensional analysis for you. Okay. you want to convert that time, 8 minutes, 25 seconds to seconds. So you need to convert the minutes to seconds and add it to 25. Then you want to use the conversion factor so that the seconds will cancel, seconds per mile, and that would be the speed of light. And then you want to convert miles to feet, feet to inches, inches to centimeters. And we've already done that. And then you want to convert using the penny information, how many centimeters to millimeters, you know that. And I tell you that a penny has a diameter, that's the size of a penny, of 1.95 centimeters. So for every 1 penny, you can say that it's 19.5 millimeters, okay, or 1.95 centimeters, and that'll be the answer. So for this problem, I actually set it up for you. And you don't have a mathematical equation. You just let the units solve the problem for you. And if you do this, then you will be able to answer the number of pennies it takes to stretch from planet Earth to the sun based on time.